Hello, boys and girls in Math 6 and in pre-algebra, in case you fall upon this. Today we're going to talk about a histogram. We haven't talked about histograms yet. We will talk about them today in class, so if you get to this blog post before school begins on Friday the 7th, you'll have a little bit of heads up on everybody else. So taking a look, a histogram is a great way to organize large groups of data. Many of you will say, oh, a histogram looks like a bar graph. And it does in that they're bars, there's rectangles, there's boxes that are on this, I don't want to call it a graph, but this graphical representation. Now, what happens is, in a bar graph, you'll notice that the bars are separated, they're not touching. In a histogram, each bin or category, as I will call them, share a common side. So instead of getting into too much, I'm going to just jump right into it and we'll kind of work with this and learn this together. So I have a bunch of data here, and typically data is not in order from least to greatest, so I've taken the privilege of organizing this from least to greatest to save some time. As I said, this is going to be our test data from, let's just say it's our post-test coming up here, our Unit 1 post-test, our Math 6 Unit 1 pro-test. So with every graph or any kind of data organization organizer we need to have a title. So we're going to call it Math 6 Unit 1 post-test. These are percents, not number correct. Now, the thing we are used to seeing with a bar graph is, pizza, taco, chips, soda. We have numbers down here instead with a histogram. And the numbers are going to represent different ranges or spreads that our numbers will fall into. Now my minimum is 45, my maximum is 100. So that's a pretty large range, a pretty big measure of spread. So I'm going to kind of try to choose different spreads or ranges that any of these pieces of data will fall into. So I know at the very minimum, or at the most, my smallest has to be 40 or a little bit less, and I'm not going to need over 100. So I always try to go by, this is a safe bet, because this data is so large, I'm going to go by tens. But I'm not going to start with 50, because if I start with 50, I would go over 45, I'd admit it. So I'm going to start with 45 and add 10 to 45. And let me shrink the font on this just a tad. So let's add 10, because I want my spreads to be 10, my range to be 10. So I'm going to go 45 to 55. I'm going to space over 1, 2, 3, 4, 5. Okay, now, what's 1 after 55? 56. So I'll go 56 and add 10 to 56. I get 66. Now, let's talk about why I don't have two 55s here. If I have two 55s, I'd have to argue, well, which one does that piece of data go into? This bin or this bin? You can't put it in both, then you will have a misguided or misleading histogram. So you can't do that. So you have to, when you're making your ranges, you can't have numbers overlap into two different categories, because then you won't know where to place that piece of data. So again, I'm going by 10, so my next number after 66 will be 67. I add 10 to 67, I get 77. My next number after 70 is 78, and I will go to 88. My next number after 88 is 89, and that will go to 99. And I'm going to go 100 plus, so 100 or anything more than that. I'm going to slide this over, I'm going to space this out a little bit more. Okay, let me just double check my ranges here. Remember what I said, I'm going by tens, so 45 to 55, okay. I don't want to overlap, so I go one number up, 56 to 66, okay, that's up there. I don't want to overlap, so I go 67 to 77. Okay, I don't want to overlap with 77, so I go to 78 to 88. Don't want to overlap with 88, so I go 89 to 99, and then anything 100 or greater. Now, these are let's get these are percents, if I could spell, percents on assessment. Okay, that's our x-axis. We also have to have a y-axis. Now, what I'm really figuring out here is number of times something happens. So how many times or how many instances where there are kids that score between a 45 and a 55? Hopefully not many. So I'm going to start chunking data. I'm going to start chunking it. So anything between 45 and 55, let's put a circle around. Okay. There's only 2 pieces of data there. That's good. I don't want a kid scoring that low. Okay, now I go 56 to 66. So anything that falls between 56 and 66 will get chunked together. 57, yes, 58, 62, 62, 65, all the 66. Okay, that is another chunk of data or another bin or category. Now I go 67 to 77. There's another chunk or bin or category of data. Now I go 78 to 88. Okay, 85, 85, 85. Okay, good. Now I have 89 or 90, 89, I'm sorry. 89 to 90. 89 to 90, that's all that. And now I have my hundreds. Now this is important to do, boys and girls, because this is going to help us establish our y-axis. The numbers are going to go along our y-axis. Now this is going to be called our frequency. You should remember that from a frequency table, the number of times something happens. So let me type out frequency, and I'm going to rotate it here in a second. Let's see if it allows me to do that. Let's click here, and we'll rotate the frequency. Okay, and that just means the number of times something happens. I'm going to put it off to the side here. Now, let's look at our categories. Between 45 and 55, I have 2 occurrences. Between 56 and 66, I have 1, 2, 3, 4, 5, 6, 7 occurrences. Between 67 and 77, I have 1, 2, 3. So 7's still my largest. Between 78 and 88, 1, 2, 3, 4, 5, 6. Another 7, okay. And then between 89 and 99, 1, 2, 3, 4, 5, okay. And then 100 or more, 4. So what that tells me is that my frequency on here, this y-axis, the values, I'm going to use this for a pen. I'm going to start with 0. And we've been talking about intervals. So I'm going to start with 0. And at the very highest, I have to get a 7 because my largest category bin has 7 pieces of data organized in it. So I'm going to count by 1. So let's go 0, 1, 2, 3, 4, 5, 6. I'm running out of room, so all I'm going to do, just like you could do with a pencil, you can erase. This will be my erasing. Let's do this. Stretch it out a little bit. I'm even going to move my thing here. There we go. Alright, now I can go 7 up here. Now, it's a little bit tough. I'm going to even put a little line here. So that's 6 there, that's 5 there, that's 4 there, 3, 2, 1. Alright, and the 7 will be at the very top. Now, let's go back, and now is when I start to make my bins or my categories. So, taking a look, how many numbers fall in between the range of 45 and 55? 2. So I'm going to go here, and there is my bin for 2. Now let's color that in so we can see it a little better. Okay. Now let's make a new bin. And I'm going to cheat. Oh, wait, oh, what happened here? There we go. Stuff's moving on me. Let's try floating that down. There we go. Alright, so that's a bin of, so there's 2 numbers that fall between the range of 45 and 55. Let's make another. I'm just going to duplicate this. Okay, how many people scored between a 66 and or 56 and a 66? Let's go back to our data. 1, 2, 3, 4, 5, 6, 7. So this must stretch all the way up to what? 7, because that score happened 7 times. Okay. I'll change a color. Usually I don't do this, but just so it stands out a little bit more. Okay. Now let's take a look. Our next category, our next range, our next bin has numbers that fall between 67 and 77. 67, so 69 would fit that category. 74 and 76. You know what I should really be doing? I should cross these out so I don't use them again. So I don't need those. I won't need those. 69. Okay, so how many is there? 3. Okay, so it's kind of touchy today. Duplicate this. We have 3. I'll move it over here to the side. Make this a little bit bigger. Because remember, they want to share a common side. So we said we had three times this occurred. So does that kind of come across 3? Yep. Okay, there we go. I'm going to change the color so we can see it a little better. Okay, now I have another, let's see here, I have 77 to 88. Let me cross this out here because I already used this data. 78 to 88. 1, 2, 3, 4, 5, 6, 7 times that occurred. So hey, guess what? I'm just going to duplicate this one. If it wants to stay still for me. Alright, so let's duplicate that. And that was 7 as well, so that'll go right here. Notice again, in a histogram, the bars or the bins or the categories share a common side. Alright, so that's that data. Okay, now I have 90, 92, 94, 95, 97. Those would all fit in this bin with an 89 to 99. So we take a look here. I'm going to duplicate this. You would obviously just redraw another rectangle. And I'm sorry, how many did we say we had? 1, 2, 3, 4, 5. There's 3, 4, and 5. Okay, good. Alright, and finally, we have hundreds or more, which again, it's an assessment. We're not going to have really more than 100. I don't get bonus. So we have 4 of those. So I am going to duplicate the yellow. Come over here. Scroll this up. And we said how many we have? 4. Alright. So there is my histogram. Now these are nice to organize chunks of data, to look at them as kind of groups, or look for the way the data is distributed over a large range. But as far as if I just had these, I couldn't tell you how many people scored a 67 or a 70 or a 72. These are just nice to organize data into kind of bins or categories to see the way the data is distributed. I can tell you by looking at this, I had way too many kids get between a 56 and 66, which is like a F and D. I could tell you that I had several kids get a 78% or higher. We had 7 here plus the 5 here. That is 12 plus the 4 here. That is 16 kids. I'm happy with this part. That's a nice distribution. I would like to see some of these people move up possibly. To figure out a mode, I can't really even tell you the mode for this set of data because I don't know what number appears most often. I don't even know that if I don't have this data, I can't even tell you the range because I'm not quite sure if I don't have this data if 45 is the lowest number and 100 is the largest. So again, they're just very good at showing the way data is distributed over a large range. Hope that helps a little bit with histograms. Take care.